Hey, this is Mr. Olmec, and we're talking about section 5.3, and in particular we're talking about how do we go from the equation of a rational function to the graph of a rational function. And so you'll see over here on the left-hand side we have 9 different things that we need to be able to do. If we do all of those and we use the graph, we can figure out what does this graph actually look like. So we're going to start off with factoring. So we take both the numerator and the denominator and we try to factor them. So you'll notice the numerator is a linear term. It is unfactorable, so we leave it as x plus 8. The denominator is quadratic, and you'll notice we can factor this as x times x plus 2. Since both terms had an x, we divided it out. Alright, and that's step 1. We factor the numerator and denominator. Step 2 is to find the domain. Our domain, as we've done before, is you take the denominator and set each factor not equal to 0. So x is not allowed to be 0, and x plus 2 is also not allowed to be 0. Alright, so you'll notice the first factor, x is not equal to 0, is already solved. We don't have to do anything. The second one, we would subtract 2 from both sides, so we had x is not equal to negative 2. Alright, and so our domain in this case is going to be the set of all x such that x is not equal to 0 or negative 2. And we have our domain. That is step 2. Step 3, we're going to look at the equation we have once we factored it and see, can I simplify this? So are there any values in the numerator, any factors in the numerator and denominator that are the same that I can cancel out? So you'll notice the numerator has an x plus 8, the denominator has an x and an x plus 2. None of those are the same, so we are not able to simplify in this case. If you are able to simplify, what that's going to do is it's going to create a hole in our graph. But we aren't there yet, so when we get to that example, we'll talk about that in a little bit more detail. We were done with step number 3. Step number 4, we're going to find the x-intercept and the y-intercept of this equation. So let's start with our x-intercept. Our x-intercept is starting by plugging in a 0 for the y and then solving for x. So we have 0 equals x plus 8 over x times x plus 2. So to solve this, I would multiply both sides by x and x plus 2, or think of it as cross multiplying. So if I multiply this across to 0, we're just going to have 0 equals x plus 8. And then solving, I would have x equals negative 8. So that means on our graph, so if we come over here to our graph, if we designate just this value here, we call this negative 8. That means our graph is going to cross through that point. Then moving forward, we need to find our y-intercept. So for our y-intercept, we're going to replace all the x's with zeros and simplify. So if we take the factored form, we have 0 plus 8 over 0 times 0 plus 2. If we simplify this, 0 plus 8 is 8. 0 times 0 plus 2 is 0. And this is undefined. So what that means is on our graph, the graph of our rational function will not touch the y-axis. This means that we just don't have a y-intercept, and the reason is because this value is undefined. So undefined values do not exist on graphs. Alright, next thing we need to do is find the vertical asymptote. So the vertical asymptote is going to look similar to the way we found the domain, but it's just going to be equations. So if I want to find the vertical asymptote, our vertical asymptote is you set the denominator, each factor in the denominator equal to 0. So we have x equals 0 and x plus 2 equals 0. So if I have x equals 0, that one stays the same. Subtract 2 from both sides, and I have x equals negative 2. So what we want to do is we want to take these two equations and we want to graph them. We're going to graph them in a different color. I'm going to graph them in red as dotted lines. These are not actually part of the graph. They're just asymptotes, which are values that our graph is going to approach, but it isn't actually part of our graph. So I'm just going to call this value here negative 2. And so we're going to have a dotted red line here at negative 2. And then I also have x equals 0. So x equals 0 is the vertical line that goes through an x value of 0. So I'm going to have a dotted red line here along the y-axis. So our graph is going to get close to these values, but it's not actually going to cross the value of negative 2 or a value of 0 whenever we get to the graphing part. All right. The next part that we want to look at is we want to look at, all right, on either side of our vertical asymptotes, we need to see what is happening. Are those values positive or negative? So this is where we're going to use the value. So we're going to use all of our x-intercepts and all of our vertical asymptotes to make a number line. And we're going to do an analysis of this problem. So whenever I look at our number line, we have negative 8 is an x-intercept, negative 2 is a vertical asymptote, and then 0 is our other vertical asymptote. So through analyzing our equation, remember our equation is x plus 8 over x times x plus 2. We're going to take a value from each interval here. So we're going to take 4 values and plug them into this equation and just see if it is a positive value or a negative value. And so I'm just going to do this really quickly. So if I take like negative 10, for example, so a value from here, that would make this parentheses negative, this parentheses negative, and then this factor negative. So 3 negatives will make a negative, so all values over here are negative. Whenever I look at this again and I try to take, let's say, a value here, negative 6, that would make the first factor, negative 6 plus 8 is positive, negative 6 is negative, negative 6 plus 2 is also negative, so a positive and 2 negatives is going to net us a positive value. If I take a value here, let's say negative 1, that would be positive, positive, negative, positive, positive, negative is a negative value. And then if I take a positive value over here, so like 7. So plug in a 7, that's positive, 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 3 positives is a positive. All right, and so what this means is on this graph, remember we have asymptotes at negative 2 and at 0. So in between negative 2 and 0, the entire graph is negative. Just to the left of negative 2, the graph is positive, and just to the right of 0, the graph is also positive. So what this is going to look like when we go to graph this is something like this. So in between negative 2 and 0, our graph is negative. So I know our graph is negative, so it's going to approach the negative side, or it's going to approach negative 2 and 0, going towards negative infinity on both of those. In between negative 8 and negative 2, it is positive, so I know this graph has to be positive, so it's going to approach this way. And on the right side of 0, we have positive values, so I know it has to approach infinity, and I know it's not going to cross the x-axis anywhere over here on the right-hand side because we've already found all the x-intercepts, and this is the only one. Therefore, it has to stay positive, so our graph is going to be positive here. We don't know exactly what it's going to do at the end. We're going to find that out shortly. But for now, we know that it is going to approach infinity on this side. And that's what step 6 is asking us to do. Step 7 is looking for the horizontal asymptotes. So our horizontal asymptotes are found using, so when we have our horizontal asymptotes, all we're doing is we're comparing the degree of the numerator and the denominator. And so we have 3 things that can happen. So we're looking at the degree of the numerator and denominator. So if the degree of the numerator is larger than the degree of the denominator, there's going to be no horizontal asymptote. If instead the degree of the numerator is less than the degree of the denominator, that means the horizontal asymptote will always be the equation y equals 0. And the third thing that can happen is if the degree of the numerator is exactly the same as the degree of the denominator, what you're going to do is you're going to have an equation. It's going to be a y equals equation, and it's going to be y equals the leading coefficient of the numerator divided by the leading coefficient of the denominator. So you would look at the numerator, find the leading coefficient, just some number, and we're going to divide it by the leading coefficient of the denominator. Whatever value that is, there will be a horizontal line through that value on the y-axis. So in our particular case, because we have x plus 8 over x squared plus 2x, the degree of the numerator here is 1. The degree of the denominator is the highest exponent is a 2. So since the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is going to be y equals 0. And so when we come back up to our equation, that means when we look at our asymptote, it's going to be here across the line y equals 0. And so we're going to go horizontal asymptote across that y equals 0 line. Alright. The last thing we're going to do here is, does this line cross the horizontal asymptote? And so this is where you're going to take your original equation. So we're going to go y equals x plus 8 over x squared plus 2x. And we're going to plug in our horizontal asymptote in for y and solve. So in this case, our horizontal asymptote was y equals 0, so we're going to replace y with 0 and then solve. So by solving, we multiply both sides by x squared plus 2x. So if I multiply this side by x squared plus 2x, it cancels out. Multiply 0 times anything, it's going to stay as 0. So really we're solving the equation 0 equals x plus 8. We solve it and we get x equals negative 8. That means, yes, it is going to cross the horizontal asymptote at x equals negative 8. And we've already seen that on our graph because the graph touches here. The last thing we do is we use the analysis that we've done before. To the left of negative 8, it's got to be negative. To the right, it has to be positive. So we're going to finish out our curve. So to the left of negative 8, it's negative, but it's going to approach 0. So it looks like this. To the right, it stays positive, so it never crosses that axis. And that's what we do to graph these.